Hello everyone. Right now we need to talk about course module and lab module number 9. This is referring to the stepper motors, right? So let's get right into that. Stepper motors. Basically there are two types of the stepper motors. If you look at these structures, the very first one is what we call bipolar stepper motors, right? If you look at the internal structure, there are two coils, right? A naught, 1A, 1B, it stands for the same coil. B, B naught, 2A, 2B, that's the same coil. So basically you got two coils, 4 leads. That's what we call bipolar stepper motors, all right? And the other type, if you look at that, let's move it down, we call it unipolar stepper motors. The unipolar stepper motors basically is very similar as the bipolar stepper motors. They are still two coils, but each coil is center tapped. That means you're going to have 4 leads, 2 out of each coils, and 2 additional leads, 1 out of each center taps. So if you look at the structure of the unipolar stepper motors, they're going to have center tap, AB plus C and D, or AB plus plus C and D, or A plus plus B, C plus plus D, is different configurations, all right? So let's go back to the previous one. The bipolar 2 coils, all right? Enable to control the stepper motors for the bipolars, you need to control the direction from the current direction flow from A to A minus, or A minus to A, B to B minus, or B naught to B, vice versa. Then you will be able to control the rotors, all right? And if you look at the unipolars, basically you either turn the half coils on or turn the half coils off. So normally we take the center tap, 1 or 2, or regardless how many the manufacturer bring it out, you tie them together, then you ground A, ground B, ground C, ground D, either one. That will allow you to control the direction of the rotors. And there's another one come in the middle of the bipolar and unipolar. That is the universal type of stepper motors. If you can distinguish which type is what you look at the leads. If you look at the unipolar stepper motors, the leads of this kind, if you got 5 leads or more, that means if I ignore this plus, all right, look at the sentence, if I ignore this plus, the other plus, if I just use A, B, C, D, this becomes bipolars. But if I utilize these 2 plus, tie them up together through the power source, then you got A, B, C, D, depends on the current flowing through the A, through the B, through the C, through the D. That will be the conductions of each half of the coils. That becomes the unipolars. Or if you have A leads, basically they bring all the coil out, then you can tie it up this A to A 2 plus becomes AB, tied up this 2 plus becomes CD, that's bipolar. But if you tied up A plus plus all together, that becomes unipolars, all right? Let's take a look at the control sequence. Please bear in mind the structure, hardware structure is a little bit different, but the control strategy basically is the same. Remember the bipolars. We need to alter the current direction flow. If you look at the 2-phase control, all right, 2-phase control give you the full torque. If you got 1 dash 1, that means you have plus, you have current from the A to the A naught or A start. If you have a B naught going to the B, all right, that will give you 1 position. If you keep A to A naught, then your reverse becomes B to B naught. That's another position. Then if you reverse A, That means A naught goes to A, then B goes to B naught. That will be another position. Then if you look at it, if we reverse the B, which means you got B naught goes to B, then you got A naught goes to A, that will be another position. If you count those bits, say you have one current flow with 1 bit control, the other is 0, then the other current flow is 1 and 1, 0. Then you read out those binary, that's 1, 0, 0, 1, that's 9, 1, 1, 0, 0, that's C, 0, 1, 1, that's 6, 0, 0, 1, 1, that's 3, then it repeats from here, continues, all right? That will allow you to rotate the rotors because the magnetic field change based on the binary bit is sent out, then the rotors will rotate certain degree, I think it's 0.8 or 1.2 degree per step. Then if you alter those binary in the amount of time delay between each step, basically you rotate the shaft in one direction. If you want to rotate the opposite direction, then you go to opposite from originally you get 9C63, 9C63, that will give you one direction. If you go to the opposite, 36C9, 36C9, that will give you the opposite direction. As far as the speed of the rotors, that amount of the time delay is introduced in between the 4-bit streams. That's how you control the bipolar stepper motors, all right? Enable for us to control the bipolar stepper motors, let's move on. Then you need to have H-bridge, all right? Say we have AB in this type, CD in this type, which is 1 coil, 2 coils. If you set up 4 switches, these switches are available on the trainer board. If you turn switch 1 and 4 on, 2 and 3 off, you're going to have a current flow from A to B. Opposite, you turn 1, 4 off, 2, 3 on, you're going to have current from B to A. The same thing on the switch 1, 5 and 8 on, 6 and 7 off, you're going to have current flow from C to D. And then if you change that, if you have 5 to 6 off, 6 and 7, 5 to 8 off, 6 and 7 on, you will have a current from C to D. That's bipolar configuration. So each coil requires 4 switches. On the trainer board, you will have 8 FETs. So half of that control 1 coil, the other half control the other coils. So you need 8 switches to control the bipolar stepper motors, right? Now let's come back to the sequence of the unipolar. Unipolar, basically you turn the current on or off. You really don't alter the current flow directions. If you look at the sequence, we usually look at the 4-step instead of half-step. All right. If you have 1, 0, 0, 1, basically the 1, 0, which means the step, this is on, that's off, that's off, that's on. So you have basically 4 coils. A, B, C, and D. Okay, that's A, B, C, and D. I'm sorry, I have to read horizontal. So you will have A on, B on, C off, D off. All right, in this one you read horizontal. The previous one you read vertical. So A on, B on, C off, D off. Then you move on to the next one. 0, 1, 1 means A off, B on, C on, D off. Then you move to the horizontal next one, A off, B off, C on, D off. That's 3. Then move to the next one is A on, B off, C off, D on. That's 9. So if you look at the number sequences, C639, 6639, you get the rotor in one direction. If you go opposite, 936C, 936C, the rotor goes the opposite direction. The speed basically the same thing, time delay in between the steps. So if you look at it from the software control point of view, it actually makes no difference between the bipolar or unipolar stepper motor control. The software is basically identical. But if you look at the switch configurations, For a unipolar, since you got 4 coils, center tab, so you just need 4 switches to turn them on or off, A, B, C, D, all right? It's the same number of sequence that will allow you to control the unipolars, all right? So let's come back to for comparisons, all right? Bipolar, unipolar. If you are compare apple to apple, orange to orange, the same configurations for bipolar and unipolar. Actually, bipolars will produce more torque because they utilize the 4 coils to have the current flow one direction compared with the other directions. But if you look at unipolars, you allow the current flow 1A, B, C, or D, basically half of the coils. So from the comparison point of view, bipolar produce more torque with the same structures, but the bipolars takes more resources, 8 switches to control, and unipolars produce less torque, but they just need 4 switches to make that control. If we go, and the handout tells you a little bit more detail, okay, the same thing, basically the numbers. We have talked about that. The driver circuitries. If you look at the trainer board on the left side, there's an LED. It goes through the optical isolators. From the optical isolator, it controls the FETs. So you have out X ground. Basically, is totally separated from the digital side, the I/O and ground. You are required to use the VCC. So if you produce the logic 1, it turns on the optical isolators. Basically, it shorts the FET drain and source. You short these 2 leads, and it produces 0.02 to 0.05 ohms resistance only. So by hooking up this, you will be able to control a switch on or off. And these 2 leads out of out X and out X ground, basically the out X is shorted to ground. Certainly before the out X, you should have a coil there, then you have a VCC. So you provide the logic, the VCC is going to go through the coil from the out X to ground. That's the switch functions. The reason we use the optic isolator is to eliminate any contamination, any spike, any noise out of the high current. So it will not interfere the logic side of the signal from the microcontrollers. But if you want to form an H bridge, remember we need, if you look at this, all right, we need 4 switches per H bridge. So total will be 4 switches. Enable for us to use that, if you have to look at the schematic. You need 4 FETs. Each FET will be controlled through the optical isolators, which is on top over here. Each one, the gate control, which will be here. But they will be controlled through the optical isolator, through the digital I/Os. So if you configure those 4 FET switches in this format, then you put your coils in these 2 terminals. That will produce 1 H bridge. For the bipolar, you need 2 of them. All right, that's another one for constructions. You just follow those leads name and short them. That will give you the H bridge that allows you to use bipolars. Certainly, more and more you can get is universal. So it depends on the application requirement. You can make it as a bipolar or unipolar. But keep in mind, unipolar use half of the coil, so it produces less torque. Bipolar use the 4 coils, then it produces more torque, but you need more resources. That means you need 8 switches per stepper motors, right? And this is what we briefly talk about the stepper motors, and then there will be a demo source code for you to see how to run on the trainer board. Thanks for listening. Bye.